A retired U.S. general sits down in late September 2025 and says the quiet part out loud. A former defense secretary just ordered hundreds of generals and admirals to a short-notice briefing at a Marine base in Virginia. He's seen decades of war rooms and readiness drills, and still calls this one unprecedented, bizarre, unlike anything I've ever seen. On its own, that's a headline. But the same month, telescopes from Chile to Hawaii start tracking an interstellar visitor, 3I/ATLAS, that refuses to behave like a normal comet. Put those two timelines on top of each other, and you don't get tinfoil, you get questions. Quick pit stop before we dive deeper. If you appreciate data-first breakdowns without hype, hit subscribe right now and tap like. It helps this reach the people who want signal, not noise. Here's the spine of this story. We have a hyperbolic traveler slicing into the inner solar system, radiantly bright with a carbon-dominated coma and outgassing rates that should shove it around like a sail in a stiff wind, but don't. We have a path that threads the lanes of major planetary orbits with uncanny convenience for observation windows. And we have a sudden surge of interest from agencies that don't usually care about just another comet. NASA and ESA, of course, but Space Command, NORAD, and intelligence branches assigning premium sensor time, that's a different tier. Why the attention? Because modern space awareness isn't just people pointing telescopes anymore. OPIR, overhead persistent infrared. Satellites built to catch missile plumes can see thermal anomalies far from Earth. Deep space radar like Goldstone can sniff out surface types. Ice scatters, metal specularly reflects. And AI pipelines, think Project Maven class models, chew through optical and infrared streams in real time, flagging patterns humans would miss. Clock-like light curves, thrust-like coarse nudges, heat spots that stay put while the nucleus rotates. The result isn't a conspiracy board, it's a ranking system. Most objects fall off the list. Outliers escalate. 3I/ATLAS hit 3 flags. CO2 is pouring off at on-the-record rates, on the order of 150 kilograms per second, which should impart measurable non-gravitational acceleration. Yet the drift stays modest. Do the math backward and you get a minimum mass in the tens of billions of tons, or a nucleus that's smaller than the glare suggests, but somehow venting with wild efficiency. Either way, it's perched on the edge of our usual models. Trajectory threading. It doesn't buzz planets, but it skims their orbital lanes at just the right epochs. Mars instruments in position in early October. Ground telescopes at prime angles near perihelion. Long baseline arrays warming up right before it slips behind the sun. You can call that luck. You can also admit it's the kind of luck that makes analysts zoom in. Timing and tasking. The observation campaign went from interesting to urgent in days, and multi-agency at that. Add a real-world, high-rank, short-notice briefing with no stated agenda, and you have a picture that demands a sober walkthrough, not speculation. So let's walk it. The professionals don't start with, is it alien? They start with disqualification. What must be true if it's natural? Thermal sanity. As it nears the sun, warm zones should map to active jets, not to fixed hotspots that ignore rotation or solar geometry. Trajectory sanity. Venting should push in predictable directions. If the path bends against the thrust of vectors implied by the gas jets, that's a red flag you can't hand-wave. Light curve sanity. Natural bodies tumble irregularly. Brightness flicker looks messy. If you see metronomic pulses over long windows, that's pattern, not chaos. Radar sanity. Ice/dust gives diffuse returns. Metal and processed composites tend to ping back cleaner, more specular echoes. Not perfect proof, but a strong hint. Multi-sensor agreement. IR, optical, radar should tell the same story. Contradictions escalate review. So, why would the Pentagon care if all of that still nets out comet? Because risk math isn't about what's likely. You don't need to believe an object is controlled to ask, what if it were, could we detect it? Could we verify it? Could we protect assets if it fragments? And that's where 3I/ATLAS gets sticky. The CO2 to H2O ratio looks weirdly high compared to garden variety comets. The drift is lower than you'd expect for the measured outgassing. The brightness screams big, but resolution limits mean the nucleus could be smaller, with the coma doing most of the showmanship. Two natural explanations explain the pairing. A, it's massive enough to shrug off vent thrust, or B, it's visually loud with a relatively modest core. Both live inside physics. Both are rare. Either keeps the object on a watch list until more data land. Behind the scenes, the playbook is mature. NASA drives the science and public comms. The Planetary Defense Coordination Office runs hazard models. Space Force handles space domain awareness, including cislunar tracking and anomaly flags. SETI post-detection protocols sit on the shelf, not because anyone expects to use them, but because you don't draft procedures after the moment you need them. If any single box breaks, non-natural motion, narrowband radio locked to the object, radar facets that repeat like engineered panels, the status bumps a tier. Not to panic, to precision. The retired general's comment still matters. You don't pull hundreds of flag officers into a room for trivia. Whether that session centered on culture and readiness or included space situational awareness threads, the scale tells you priority. Meanwhile, the science campaign is doing the slow, disciplined work, constraining nucleus size from Mars orbiter photometry, cross-checking thermal spikes with vent models, and syncing multi-sensor timelines to beat down uncertainty. If all measurements keep landing inside natural bounds, this file closes as a fascinating but explainable interstellar comet, well documented for when Rubin starts finding them by the dozen. If even one clean measurement refuses to fit, especially motion that can't be produced by gas, then phones melt and the next playbook opens. The cleanest proof tests and why motion is king. The exact sensor combos that would force a status change, and what a rapid intercept mission would realistically look like in 2025 logistics. Not sci-fi, just the fastest path to answers. When scientists talk about anomalies, they don't start with conspiracy, they start with math. And the cleanest math in this whole 3IATLAS case isn't about chemistry, it's about motion. Because everything else, light, heat, radar, can be misread. But trajectory, that's physics written in stone. If you appreciate factual, cinematic breakdowns like this one, hit subscribe right now. It helps keep this kind of independent analysis alive. Here's the hard truth professionals focus on. Motion is the one thing you can't fake. Comets vent gas as they warm up, creating small thrusts. Those thrusts produce measurable drift, called non-gravitational acceleration. The direction and strength of that drift should line up neatly with where the jets are firing and how much gas is leaving the surface. With 3IATLAS, it doesn't. Astronomers logged outgassing equivalent to 150 kilograms of CO2 every second, enough to nudge it off course by a visible margin. But observations from 227 observatories show a drift below 15 meters per day squared. That shouldn't happen unless one of two things is true. The object is incredibly massive, so the thrust barely moves it. Or our view of the gas and dust halo is deceptive, and the true nucleus is smaller, but somehow venting far more efficiently than models predict. Either way, it means 3I/ATLAS doesn't sit comfortably in the ordinary comet drawer. Now, here's why motion outweighs everything else in the playbook. Thermal data can trick you. Dark patches absorb more sunlight and look like heat anomalies. Light curves can mislead. Dust jets flash like a strobe and mimic rotation cycles. Radar pings can lie. Signal angles and rough terrain create false geometric echoes. But if an object ever makes a course correction that contradicts physics, that's definitive. If its path shifts against the direction of its own outgassing, or if acceleration appears without a visible venting event, it's no longer ambiguous, something applied force that shouldn't exist. Defense and science agencies treat that as a red team scenario. Low probability, high consequence. The reaction wouldn't be a Hollywood scramble. It would be a disciplined chain of verifications. First, cross-sensor validation. Infrared satellites, ground radar, and optical telescopes all compare their time-stamped data. Then, independent replication by global observatories. Only after that do interagency coordination lines engage. NASA, ESA, JAXA, Space Command, and the Planetary Defense Coordination Office sharing telemetry. Right now, they're already doing the prep work that matters before any anomaly escalates. When 3IATLAS made its 30 million kilometer pass near Mars on October 3rd, the Mars Reconnaissance Orbiter and European craft had prime vantage points. Those close-range measurements can refine its size and density more precisely than Earth-based scopes. If the core turns out smaller than 5 kilometers, the math balances. If it's larger, the anomaly deepens. Simultaneously, the James Webb Space Telescope and others recorded infrared spikes, heat emissions that should sync with venting activity. If they don't, if hotspots appear in places that sunlight shouldn't reach, that mismatch becomes a new flag. Deep space radar attempts are still cued to test for coherent facet returns. Not proof of structure, but evidence of surfaces too smooth to be random. This layered watch is how professionals guard against panic. You don't need aliens to justify vigilance. You just need unknowns inside operational space. Satellites route our communication, GPS underpins logistics, and missile warning systems rely on clean orbital awareness. If something massive moves unpredictably near those domains, you treat it like a potential hazard first, curiosity second. Privately, multiple agencies already model rapid intercept scenarios, not contact, observation. A small probe, ride-sharing on a commercial launch, could reach a passing object within months. The tech exists: solar electric propulsion, AI-guided navigation, compact spectrometers, and cameras. The goal would be simple: image the nucleus directly, capture close-range composition data, and confirm what the distance sensors can't resolve. Nothing speculative, just the scientific version of go look for yourself. What about signals? SETI and radio observatories are always listening, but the noise floor is vast. If any narrowband emission stayed locked to 3IATLAS's frame, that is, moving with it through space, it would jump straight to top priority. Natural radio bursts are messy and broadband. A tidy signal staying glued to one object would be, by definition, artificial. So far, there's nothing like that. The data, for now, are strange but stable. Massive body, odd chemistry, predictable motion. That combination keeps the file open, but labeled unusual, not hostile. Still, the deeper you look, the more the scale of human readiness shows. The same OPIR constellation that monitors missile launches can watch thermal spikes beyond Mars. The same AI that flags atmospheric tests can flag light curve anomalies. The machinery of detection already exists. It's just being used in a new way. So, what comes next? Simple. They watch, record, compare. And for all the public calm, insiders know the unspoken rule. If 3I/ATLAS ever bends its path without a physical cause, it graduates from curiosity to classified. Until that moment, it remains an ancient, beautiful, and thoroughly confusing guest from deep space. What evidence would end all debate instantly? What historic parallels hint we're overdue for another surprise? And 5 viral title variations you'll want to steal for your own coverage of this unfolding mystery. There's one thing that could flip this entire story overnight. A single clean motion anomaly. No light flash, no heat spike, no signal. Just movement that defies physics. That's what scientists quietly call the line in the sand. If 3I/ATLAS ever accelerates or shifts in a way that can't be explained by its own venting, it's not a comet anymore. It's an engineered object. Because in orbital mechanics, math doesn't care about opinion. Forces either add up or they don't. But before we chase that what if, remember, this story isn't about hype, it's about method. That September briefing full of generals, admirals, and defense staff wasn't panic. It was contingency, the structured kind. When something big and fast moves through our solar system and doesn't follow the expected playbook, the job is to ask every question early while staying calm enough to hear the answers. Here's the final reality check professionals use. Trajectory is truth. We can predict planetary motion centuries ahead. If a comet bends its course with no corresponding thrust vector, that's evidence, hard evidence. Light curves are secondary. Repeating brightness cycles can hint at rotation, but only motion confirms control. Thermal maps are support data. Fixed heat spots that ignore sunlight direction raise eyebrows, but they're still circumstantial. Radar is the tiebreaker. A specular mirror-like return would mean smooth, geometric facets, rare in nature, impossible to ignore. That's why the defense world treats 3IATLAS as a live exercise in readiness. Not because anyone believes in visitors, but because this is how you prepare for low-probability, high-impact events. The same math used to track asteroids also guards satellites, GPS systems, and missile warning assets. And that's the real headline. When the general said, "Never seen anything like this," he wasn't wrong. The scale of coordination, hundreds of officers, overlapping agencies, shared data pipelines, means humanity's eyes in space have finally gone global. Now, the wait begins. As James Webb Space Telescope, Goldstone, and Vera Rubin Observatory pour in data, AI systems are cross-matching patterns faster than any team of human astronomers ever could. If 3I/ATLAS behaves naturally, the file closes quietly. Case study, massive interstellar comet, natural origin confirmed. If not, the next press release won't come from scientists. It'll come from governments. Before we wrap up, if you've made it this far, hit like and subscribe, then share this with someone who watches the sky as closely as you do. It's the best way to keep these deep dive breakdowns visible instead of buried under algorithmic noise. Because whether 3I/ATLAS is a cosmic accident or a message in motion, the truth will come from data, not from headlines. And that's exactly why we'll be here when the next one arrives.